Hello, welcome. Geometry section 8.1 today, geometric mean. Similar right triangles. Theorem states, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original and to each other. Reading from our example here, we have our outside triangle, ABC, which is in the middle. That is similar to triangle CBD and also to triangle ACD. So again, if an altitude is dropped, and we have it here, the altitude being dropped is CD, that forms three right triangles, and those three right triangles are similar. Alright, similar right triangles. Says, the question states, sketch the three similar triangles and write the similarity statement for them. So we have to sketch and draw out the three separate right triangles that are formed. So we have the outside triangle in red. We have the left triangle here, that's a right triangle in green. And we have the last one on the right here in blue. Okay. To draw those, you're going to need to first draw three right triangles. So let's draw three right triangles here on the left. On the right, excuse me. So here's three right triangles. The right angles are the easiest to place in the three triangles. There are two triangles that have Z as the right angle, and there's one triangle with W as the right angle. We'll make the outside triangle, the XWY, as the furthest left triangle of the three. So we'll put, without really concerning X or Y, you put X in one spot and Y in the other. So we have one listed here. Now, if you take a look at the alternative triangles, for instance, the green triangle on the left here, and then the red, the outside one, you notice that X is in the same spot for both triangles. So in our drawing of the three triangles, we'd have to put X in the same spot for the second triangle. Similarly to that, we have Y that's in the same spot for the red triangle and the blue triangle. So not on the middle triangle, but for that third triangle, we need to put Y in the same spot as well. Why did we not put Y in the second triangle in the middle there? Because that triangle doesn't even have Y in it. That triangle has X, Z, and W. And if I take a look at that triangle, it has X and Z listed, that second triangle, so my last variable has to be W. Same thing with the blue triangle. We have Z and Y listed. Why not X? Because X not involved with it, so therefore the blue one has to be W. And there's our three triangles listed with all the appropriate angles. Now the thing about those three triangles is now they are in order for the similarity statement. And the similarity statement will be as follows. Triangle, I'm just going to go in order, X, Y, W is similar to, we have the X, triangle X, we went to the top of the next, W, Z is similar to triangle W, Y, Z. And we notice the one variable that changed spots each time was the W. W here, W here, W here was in all three of the spots. And if we look at the triangle, the picture up top, we have the W there circled in blue, and it is a right angle in one, and then two separate angles for two separate triangles. So there we have the multiple spots. Okay. Next question. Identify the similar triangles and write a similarity statement for them. And that's A. B says find the height H. Find the similar triangles. Well, we just did that by drawing them. And here are the three listed. We have triangles X, Y, W, Y, Z, W, and X, Z, Y. Once you have the triangles drawn, then you can plug in the appropriate side lengths for them as well. So we have XY being 3, 1. We have the YW as H. We have YZ as 5.5. We have YW again listed as H. And then we have the last triangle, which has XZ as 6.3, ZY as 5.5, and XY as 3.1. Once we have those listed, we can write the similarity statement that goes with it. Triangles XYW is similar to triangle YZW, which is similar to triangle XZY. So that's the first part for A, which is just a restating of the problem we just did. Next question, B, says find the height H. So we have here in the bottom right, we have those three triangles listed, and what we really can do, since the triangles are all similar, is write a proportion to solve. We have that proportion listed. We have YW over ZY, so we have YW I want to get a good ZY here. We got YW over ZY is equal to XY over XZ. Taking those pieces of information and plugging them in the proportion, we have our statement here. We get those blue lines out of the way. And we have our solution. Okay, once we have our proportion, cross multiply and solve. So our approximate height is 2.6. Alright, geometric mean. This is a topic that we covered one day in class. Very briefly, but it says find the geometric mean between two numbers, 2 and 50. It's a pretty straightforward algebraic definition where you have again your two values in the top left and bottom right corner, the x's in the middles, cross multiply and solve. Geometric mean of those two numbers is 10. Okay, solving another one, 3 and 12, you have 3 over x is equal to x over 12, cross multiply, x squared is equal to 36, square root, x is equal to plus or minus 6. We don't care about the negative here, so we're left with b as our value. B is equal to 6. Alright, so we can solve that. Now, the reason why we need to solve that algebraically is because we do have to take a look at geometric mean as it is concerned with geometric concepts and figures. So the geometric mean theorems take that altitude that's dropped down from the right angle of the right triangle to the hypotenuse. Okay, we did state that all three triangles are similar, and if they're similar, there are some proportions that are held to be true. And these proportions are very important. We know that BD over CD is equal to CD over AD. We know that AB over CB is equal to CB over DB. And we also know that AB over AC is equal to AC over AD. Now, I would write all of these down because you will use these on almost all of the problems in this section and some later on. The thing to note here is that the middle sections on each one of the proportions are the same. So the reason why we need to learn how to algebraically solve the geometric mean is because now we're going to apply it with proportional situations. There's one where we have CD in the middle, CB in the middle, and AC, which takes care of the three lengths of each one of the sides of the triangle. We have the left, the middle, and the right, which are the largest sides of the triangle, or besides the hypotenuse. Alright, we will now take those three theorems and apply them in some problems. Alright, using the geometric mean, solve for x. We will use the theorem that has BD over CD equal to CD over AD, Why do we choose that? We choose that because we either have to look for what we're solving for or what we can use. The key is the middle section. The middle section here is CD. We're looking for CD, so we'll use that one to solve for. Once we have that, we take a look at our other information. We have BD, we have AD, we plug in our numbers and solve. So 3 over x is equal to x over 6. X squared then is equal to 18, and x is equal to 3 square root of 2.